upon what we have seen yesterday, we have started with PBR. I think so. We have seen one practical regarding PBR, source-based PBR. We have seen source-based PBR, if I'm not wrong. Okay, we have seen.
Yes, we have source-based here. Yeah.
Yeah, we have seen that these two loopbacks, if they are sourced, if anything coming from these two loopback networks, it should use this link. We have used PBR with the help of route maps. And if anything is coming from these two loopbacks, then it should move via this link. It should use this link. Okay. And anything coming other than these loopback means if anything is coming from my LAN user, then it should use the default, whatever is the default routing. Correct? Now we will look something like destination PBR. Let me take console. Okay. R1. Show IP protocol. I'll be running EIGRP over here for connectivity. Show IP route. These are the routes that are available. Okay. On R1. Show interface serial 3/0. Show interface serial 3/1. See, I've changed the bandwidth over here. Yesterday, I've changed the bandwidth over here. Okay. So if I see show IP route EIGRP, to reach the 12 dot network, I'm only having one path with the higher bandwidth, that is serial 3/0. Okay, 1.1.1.2. But there are two paths. Why EIGRP is not including the second path? Because it is not equal. The bandwidth on the second path is lesser than the bandwidth on the first path. Okay, so the first, it is choosing only the first path and it is the default routing. Okay, now my first thing that I need to do is, let me check if I'm having it over here. We have done this thing, this task we have done. Okay, so I have another task over here. I will remove all the ACL route maps and policies, whatever are configured. Okay, so let me see if there are any access list configured. Show access list. No access list as configured. Show run. I can see if anything is configured on the interfaces, any policy or anything. Nothing. Neither in the router mode. Nothing has been configured as per my this thing. Okay, so I have only fresh configuration. Now what I need to configure policy based on routing on R1 as per the condition. If anyone is trying to go to 12.0.0.0, means the destination is 12.0.0.0 and 12.0.1.0 network from any source, either from any of the loopback or from any of the loopback or the LAN network, it should be forwarded via serial 3/0. From where it should be forwarded? From serial 3/0. Okay. And destination, that is 12.0.0.2 and 12.0.3 network, from any source it should be forwarded via the second link, that is serial 3/1, all remaining using default routing. Now this is something about destination. Okay, we are telling that if anything is coming from any source but the destination is the first two loopbacks, then they should use the first link. If the destination is second to the last two loopbacks, then they should use the second link. And if the destination is this 20 dot network, then it should go via the default routing. Understood? So let me create some access list. IP access list extended. I'll now create extended access list, extended named access list. I'll say this is path 1. Path 1 means serial 3/0. Okay. Now here I'll say permit, I'll match the network permit IP any from any source to the destination. This is the destination from any source, and if this is the destination. Okay, this is my first access list. My second access list will say that other two networks. Okay, I'll say permit IP any from any source to this destination and from any source to this destination. Got it? I've created the access list. Let me create route map. Route map, I'll say the route map name is destination. Destination, and I'll say permit. This is my first sequence number 10. This is my first sequence number. I can give any sequence number. Suppose if I start with 1, I will give 1. Okay, permit. This is the first route map statement. This one means this is the first route map statement. Okay, so here I will match the address. Match IP address in path 1. Match IP address in path 1. Okay, so and set interface serial 3/0. Understood? See what I'm doing over here. What I did over here, I created an extended access list. I said this is the extended access list, extended named access list. And I said if anything is coming from any source, permit any source to this destination. Okay, permit any source to this destination, but do it via route map, but use the route map. While permitting, use the route map. Okay, so it will use the route map while permitting. So it will check what is the route map. It will check what is the route map. Route map is match IP address in path 1. It will go and match the IP address, and after matching it will set that for that IP address or for that network, it will set for that destination network, it will set the the link that is forwarding the traffic is serial 3/0. Exit. Now my second route map statement For second access list, I'll say match IP address in path 2 and set the interface as serial 3/1. Now I have done both the things whatever I have shown you. Okay. Now the third route map statement for all the other traffics. I need to pass all the other traffics also, like if someone is trying to reach 20 dot network, then what the route map should do. If someone is trying to reach the 20 dot network, then what the route map should do. So I will give a blank route map over here. The blank route map will tell me that allow all the others. Allow all the others, and there is no match, there is no set criteria. So it will be allowing default routing. Default routing, whatever is the default routing, it will be allowing that. Understood? Now I have to implement it on the interface, LAN interface that is connected on R1, because the traffic will be coming from there. Okay. And I'll say IP policy route map destination end. Debug IP policy to see the outputs. Okay, let me go on R3 and let me try to trace route 12.0.0.1. How it is going? 1.1.1.2. See here. Policy match using fast Ethernet zeros from fast Ethernet 0/0. Okay. The source is 10.1.1.4. Destination is 12.0.0.1. The link that it is using is this link, and FIB policy is been routed. Okay. If I give over here, the source should be my 14.0.0.1. Sorry. See again the same link, and if I go over here, policy matched, the source is 14.0.0.1, but it is going via the same link, serial 3/0, because we have configured the destination based PBR. Okay. Now if I go and if I try to reach 2.1 from the same source, which link it is using? It is using 2.2.2.2 link. It is using 2.2.2.2 link, the second link. And if you come over here, the policy is been matched and policy is been routed via serial 3/1. It is routed via serial 3/1. Correct? And if I try to trace route my 20.1.1.1 from any source, it will be using 1.1.1.2. Why? The default routing. See, on R1 the output, the source is 14.0.0.1. The destination, see here, the destination is 20.1.1.1. FIB policy matched. We have a route map created, but there is nothing in the route map. There is nothing in the route map. Okay, so normal forwarding is done for my 20 dot network, for my LAN, for my loop, for my LAN of R2. Understood? If I try it from any source, whether it is 40.1.1.1, the output would be same. See the output. Policy match. Source is 40.1.1.1. Destination is 20.1.1.1. FIB policy rejected because we have not given any policy. No match policy, no set policy. Nothing is given on that. Understood? This is my destination based.
Can
This
you
is
go?
my, sorry,
Can you go on R2 and just show history of the commands?
which command?
Uh, do show history for all the route map command what we did.
Route map I've given on R1, right?
Oh, sorry, R1. Yeah,
Do show history.
yeah, this one. Okay.
So if you didn't have the route map destination permit 3 being blank, it wouldn't allow that default route to take place. Is that right?
Yeah, if I wouldn't have given this thing, route map 3, is this is route map destination 3, sequence number 3, it wouldn't have allowed the other traffic than these two.
Got it.
Got it? This is like your permit any statement. This route map is like your permit all the others. Okay, permit all the others. Getting me?
Yes, that makes sense.
Are you taking down these?
I have already taken. Thanks.
Okay, so should I move back?
Yeah, yeah.
Now we can do it on basis of some traffics also. Like we have different types of traffics, HTTP traffic, telnet traffic. So what I can do, I can configure some type of policies based on routing on R1, that if there is any HTTP traffic, then from any source to any destination should be forwarded on serial 3/0. If there is any telnet traffic from any source to any destination, it should be forwarded on serial 3/1. All the remaining traffic other than this, like your ICMP traffic, should be using the default routing path. I can do it in this way also. So how to do it in this way? First, I need to remove whatever I have configured. Okay, so whatever I've configured, first I'll say no IP access list extended path 1 and path 2, no route map destination. Okay, then on the interface fast ethernet 0/0, no IP policy route map destination. Anything else I need to remove? Access list, route map, IP policy. Okay, now my first rule, what the first rule says, all the HTTP traffic should move via the serial 3/0. I need an access list to match the traffic. So I will say, see, we can give the access list based on the traffic, type of traffic also. So I will say extended and extended named access list, IP access list extended HTTP. I will say permit what? Permit TCP. Permit TCP from any source to any destination. Okay, that is equal to 80. Correct? Permit TCP service, HTTP TCP service coming from any source to any destination, that is HTTP, that is equal to HTTP. This is my first access list. Second access list says telnet traffic. Permit, this is also my TCP, any source to any destination equal to 23. 23. Okay.
Here, telnet, right? TCP you mentioned.
Yeah, TCP, telnet is TCP type traffic.
Okay.
Exit. Now I will create route map. Route map. We can say the route map name is services. Services. Okay. Permit sequence number 10. Okay. I'll say match IP address in HTTP. Set. Now you can set the these all commands are there in set. So we were using the interface command previously. You can set the next hop also. You can set the next hop also. So to set the next hop, you have to give set IP next hop. So I'll say set IP next hop. Next hop is my 1.1.1.2. Okay. Match and set statements are done. Now, second route map statement for second access list. Match IP address in telnet. Match IP address in telnet. Set IP next hop as 2.2.2.2. 2.2.2.2. Exit. Third route map statement for all the other traffic, and I will keep it as blank. That they can be any type of traffic, and they should use the default routing. Okay. Again, implementing on the same interface, IP policy, route map, services. Debug IP policy. Now see, I cannot show you the real-time things, but what I can do, if I try to telnet 12.0.0.1, 12.0.0.1, and I have an option over here, I can use some traffic, some type of traffic to be telneted. So I can use this HTTP traffic. Okay, I'm telnetting via HTTP traffic. I will not get anything, but you can see I got an output over here. I got a debug policy over here when it was trying. It was trying to attempt. So the source was 10.1.1.4. The destination was this. FIB policy matched and FIB routed via this interface. FIB routed via this interface. 1.1.1.2. Correct? This is what I have done. But if I do normal telnet, there is no password set. If I do normal telnet, you can see FIB policy matched and it is sending via 2.2.2.2. FIB policy is been routed. FIB policy is been routed. Got it? And if I try to ping 12.0.0.1 or let it be 1.1, see the third route map statement, normal forwarding, normal forwarding, normal forwarding. Whatever is the normal forwarding path, it is sending it via the normal forwarding.
When you say normal forwarding, do you mean it's going to look at the default route or the routing table?
Yeah, the default routing table. It will look at the default routing table. What is the default routing table for this destination?
Got it.
So default routing table is this. For this destinations, these are the default routing table. For 20 dot network also, this is the default route. The default path is 1.1.1.2. Understood? If I do it from any source, suppose I do the telnet from source, I pick up specific source. So I think so I don't have an option over here for source. Yeah. Source interface, I'll say loopback 0. Okay. You can see from 14.0.0.1 is the source and the policy is been matched is forwarding via 1.1.1.2 because I am trying to access HTTP. I am trying to access HTTP traffic. Okay. If I tried it another way, no HTTP traffic. If I tried just normal telnet, see, it is forwarding via 2.2.2.2 now. Got it? If I go to any of the destination, if I change the destination also, suppose the destination is my LAN, then also it would be same because we have said from any source to any destination, you have to, if there is, we have made a policy based on the route map, based on the route map and based on the type of traffic we are forwarding, based on the type of traffic we are forwarding. Understood? Any
Yes.
questions? Okay. We have one more task to do. Like we can do it with the help of we have packet sizes. Okay. We have different packet sizes. So what we can do, we can create some policies based on the packet sizes. If traffic with packet size less than equal to 500 bytes, it should be forwarded using the serial 3/0 link. If traffic with packet size between 500 to 1000 bytes, it should be forwarded via serial 3/1 link. All the remaining traffic means other than these two, then this should be using default routing path. We can do it in this way also. Okay, so I'll remove all the things whatever I've configured again. No route map. Also the access lists. Okay, I've removed the access list, the policy on the interface, and the route map. Perfect. Now, the first says, now I don't need to match anything. Now I don't need to match any IP address or anything. So I don't need access list over here. I will directly use route map. Route map and the route map name will be packet permit 10. Route map packet permit 10, the first sequence. I will say match. Match what? You can see here I am having a length option, packet length, packet length. So I'll say match the length. length, minimum packet length 0, maximum packet length 500. If this is the criteria, then set the interface as serial 3/0. Understood? I need to match the packet length. If the packet length is between 0 to 500, then set the interface as serial 3/0. Second sequence, if the packet length is in between 501 to, you can say, 1000 or 1000, you can say, then spelling mistakes, then set the interface as serial 3/1. Exit. The third route map statement for all the other traffic and the implementation.
Is
IP
that
policy.
best practice to always do a default route map statement for all other traffic? Is that why we do that? Is that like a best practice or something?
You should always give the, see, this is, as I told you, this is like your permit any statement. So you should always give this permit any statement. If you will not give, it will not pass any other traffic rather than these criterias. Got
Okay,
it?
so if you really wanted to lock down the traffic there, you could.
Yeah, if you want to
Okay.
lock down the traffic, you can make your mind and you can give these two route map traffic and others will be blocked if you don't
Got it.
give this.
I understand.
See, if I give permit, then by default there is a deny statement, correct?
Right, I
If
understand.
I say permit, there is a default deny, explicit deny statement is there that is running. So that is the reason I need to give a blank route map for all the other type of traffic. Got it?
Got it.
Just give me a second. I was just getting a call. Okay, so IP policy route map. The name of the route map was packet. Okay. Debug IP policy. Now let us check. Ping 12.0.0.1 and the source is loopback 0, that is 14.0.0.1. And now here I can give a size of the packet. Size of the packet is suppose 200. See, size of the packet is 200 over here. What is the default size of a ping packet? What is the default size of a ping
32
packet?
bytes. 32 bytes.
Sorry?
32 bytes.
22 bytes.
32.
32 bytes. No? Anyone else?
Maybe they are checking
64.
things.
Sorry?
64 bytes.
64 bytes. Okay, let me remove this size. What you can see over here.
100 bytes.
Default is 100 bytes for a ping packet. Okay, remember this thing.
Default is what? 100 byte.
100 bytes.
Maybe it is different for Windows then, right?
Yes,
it is
different
Windows.
for Windows.
Oh,
It is 64 bytes for Windows.
This question can come, right, in exam?
This question came in the CCNA, the last CCNA exam. This is one of the question. That is why I just got a click over here that this can be a question.
100 bytes ping packet size is for all or only for Cisco? This is for Juniper also or only for this?
No, I am talking about Cisco only.
Okay.
Yeah. Now, if you give the size as 200, let us go and check the policy. These are the 200 packets. Okay, length is 200. Policy is being routed via serial 3/0. It is routed via serial 3/0. Okay, as we have configured. Now, if I change the size to 1200, length is 1200, policy match and policy is rejected. Normal forwarding. And if I make the size as 999, it will be moving via the serial 3/1 interface. See, 999 serial 3/1 interface. So you can do it in different ways. You can make your different policies, whatever you want. Understood?
Yes.
See, it will give you a name string serial 3/1. Serial 3/1 because the packet size was how much? The packet size was 999. Okay, understood? Any questions? Okay, now we can do redistribution using route maps. We had done redistribution. We can do redistribution using route maps also. So let us see how to do redistribution using route maps. Let me open this project. Start. I'll be using R1, R2, and R3 routers. Okay. Now my plan is I'll be running OSPF over here on all the routers, and these loopbacks on R3 will be in RIP. They will be running in RIP. Understood? This is my plan. No. Just a second. Okay, so I've given you the plan. Let us quickly configure as per the plan. So I'll keep the plan over here and this thing over here so that you can see side by side. Show IP protocol, no protocol. So router OSPF1 0.0.0.0.0.0.0 area 0. Okay, all the networks. Router OSPF1 network 0.0.0.0.0.0.0 area 0. Okay, from the neighborship you can see. Now on R3 I have to be specific on R3 because R3 is also running RIP. It is my ASBR router. ASBR router. So first I'll do RIP, no auto summary. I'll say network 13.0.0.0 exit. Then OSPF. See, you are at the professional level, so you need to configure these all things very quickly. First of all, the IP addressing. The IP addressing should be very quick. 30.network. Correct? Okay. Let me go ahead on R2. Show IP route OSPF. Okay. I'm not getting the 13.network. To get the 13.network, I need to redistribute the RIP routes into the OSPF. So redistribute RIP subnets. Once I do this, if I check now, I will get E2 routes. I'm getting E2 routes, individual E2 routes, OE2 routes. Okay. Now by default, all the routes gets redistributed with metric and metric type. You can see they are defined when doing the redistribution. Okay. So metric value and metric type for all the routes will be same when we do redistribution. So in order to have different metric or metric type values for different routes, we can use something known as route maps. Okay. So how we can use route maps? Over here, route maps for redistribution. Okay, now I will give some task over here. I'll say configure R3 to redistribute 13.0.0.0/24 in OSPF with metric equal to 2000. The metric value will be 2000 and metric type should be any type. You can say, as I will say, metric type should be E2. Metric type should be E2. That is the default one. Then configure R3 to redistribute 13.0.0. or 13.0.1.network/24 and you can say one more 13.0.2./24. They should get redistributed in OSPF with metric equal to 1000. Okay, and metric type should be E1. E1. Metric type should be E1. And configure R3 to redistribute all remaining networks. All remaining networks means my last loopback. Okay, last loopback to use default things. Default things like metric will be 20 and metric type will be E2. Okay. Understood? This is the task that you need to do now. Okay. Now, first of all, I need to remove the redistribute command. I need to remove the redistribute command over here. Now I need access list to match the addresses because I am having the source over here. Okay, I'm having the IP addresses, the network over here. So access list, suppose I will take 15. I'll say permit 13.0.0.0, 0.255.255 or 0./24 255. This is for my first rule. Then access list 30 for my second rule. Okay, this is the thing. Now creating route map. route map, suppose CCNP permit 10. Now I'll say match IP address in access list 15. Okay. And set. Now what you need to set over here? You need to set, the first statement says set the metric value as 2000 and the metric type is default. So you need to set the metric. So here is the metric, set the metric. So set the metric, give the metric value. So the metric value will be 2000 for this route. Okay, that's it. If I don't give the metric type, it will take by default E2 only. Okay. Then second statement for my second access list, I'll say, sorry, not access list. I'll say match IP address in 30. And what I need to set, I need to set the metric value as 1000 and metric type as E1. So I'll say set metric equals to 1000 and set metric type as type 1. Okay. Then the third route map statement, the blank statement for all the other traffics. Okay. Now redistributing using route map, how I can redistribute using route map? So router OSPF1 and I'll say redistribute RIP subnets and here I'll use route map CCNP. Redistribute using route map CCNP. Okay. Understood? Now show route map CCNP. Just have a look at the route map, whatever we have created.
Just run also show history command to see all the commands.
Sorry?
Also run history, show history to capture the.
Do show history.
Yeah.
Done?
Yes, that.
Okay. Can we check? Show IP route OSPF. See, whatever I have configured over here, even routes for the 1 dot network and 2 dot network, and the packet size, see, it will take by default 64. Okay, so 64 plus 1000 will be 1064. Okay, then for this route, the first route, this what 2000 is the metric, and E2 by default. For this, everything is default. OE2 and 20 is the metric. Understood? You can do it in this way also. Any questions? Should we move?
I'm good.
Okay. Just a second. Okay, so now we can use route filtering also. Whatever the route filtering we had done, we can do it with the help of route maps. Route filtering, whatever we have done, we can do it with the help of route maps. So what I'll do, I'll just remove this RIP configurations. Okay, and I'll just do OSPF configuration. I'll just configure it in OSPF. Okay, so I'll say no router RIP and no inside router OSPF1. I'll say no. Or I'll reload this router completely so that all the things will be gone. Only this router. Stop and start. Okay, done. Show run Pipe section OSPF. Show IP protocols. Any network with any subnet mask. Okay, now what is my task? My task is, as you remember, if you remember, we were doing route filtering using the distribution list. Okay, so what I want that these 13 dot network, okay, 13.0.0 network should be filtered when they are going out of this interface. They should be not advertised to R2. You should not get the 13 dot network, any of the loopback on the R2's routing table. Okay, so currently if I see on R2's routing table, show IP route OSPF, I'm getting the 13 dot network. Okay, so I don't want this 13 dot network over here. So I have done it with the distribution list. Now I will do it with what? With route maps. Okay, so I'll say access list 15 to match the address. Okay, permit. This permit means I am permitting this network for the access list because I need to match the network. I need to match the network. Okay, so I am permitting this network.
Your voice is very low, Qayyum.
We can't hear you anymore.
Sorry, can you hear me?
Now, yes.
Yes, now we can.
So access list 15 permit. I am permitting this network. Okay, and what I need to do exactly, I need to deny this network, correct? I need to deny this network. So I'll say route map CCNP, and here I'll say the deny statement. Here I'll say the deny statement. So deny, permit and deny will be deny. Permitting from the access list, but denying from the route map. Okay. Now here I will give match IP address in the access list 15. So what I'm saying over here, see, what I'm saying over here, use the route map and deny it. Deny what? Whatever is there in this access list. Whatever is there in this access list. So it will go over here and it will see the access list and it will perform deny. Understood? Getting
Yes.
me?
Yes.
Now for other traffics, 20, but here it will be permit because I want to permit the other traffics as it is. Sorry, 20 blank. Okay, blank. Now implementing it on the router OSPF mode, and I'll say distribute list, use the route map instead of using access list, use the route map, whatever is going outside, whatever is going outside. And if you would have done it on the, if you would have done it on the R2, you would have given the in command. You would have given the in command. Out directions is not allowed in case of OSPF. Okay. So you need to give it on R2 only. So I have to remove all the commands from here. have to do it on R2 only, because OSPF doesn't support out direction. So access list 13 or any number 13.0.0.0, 0.255 to 55 to 55. Okay. Permit. Okay. Then route map CCNP deny match IP address in 13 exit, and the second route map statement is permit exit router OSPF1 distribute list, use the route map CCNP whatever is coming inside or whatever is coming inside. Okay, exit.
So you should redistribute everything except for the deny.
No, we are
13,
not doing
right?
redistribution.
Oh, it said distribute
We are,
route.
what I've done, I have made all in, I have removed this rip, I have made this 13 dot network to be advertised in OSPF. See, I'm not getting the 13 dot network.
That's because you're blocking it on the route map, right?
Just because I have filtered the routes. Because I have filtered the routes. I have filtered the routes. I have told that R3's loopback address should not be advertised to the this to R2. Okay, they should be not showing, they should be not present in the R2's routing table. I have
And
filtered the route.
distribute list route map CCNP. CCNP is the route filters we created.
Yeah,
And
CCNP is the route map.
That's all inbound
Traffic, whatever is coming inside. See how the traffic is going over here. The traffic will go in this way only. The 13 dot network will go inside this.
Right. Same as 11 dot would go in on 30. I got you.
Understood?
Yes, I believe so. I think I got it.
Any questions, guys? In any of the part of route filtering or PBR or anything?
This route filtering, we have you have taught us many topics on route filtering. Just summarize once what we discussed. Like we talked about passive interface. This is also a way to filter out some routing, and then distribution list, IP prefix, and then we discussed route map, right?
Yes. So whatever
Policy
we have
based.
studied, I'll just go through once again.
Yeah, just summarize this. Yeah.
So first we have started with the route filtering things. We have seen what is route filtering, what is the process of route filtering, how it works. Okay, route filtering. Now in route filtering, it is a process to allow or deny specific routes when they are advertised to the router or received. Okay.
Your voice not coming through.
Okay. Then advertise specific routes to the neighbor. If I want to advertise only specific routes, we have seen that thing also. Okay. Redistribute some routes, preventing redistribution loops. Now you might need to control exactly which routes to be advertised or redistributed, or which part to be chosen. You can advertise only specific routes to the neighbor. Path manipulation can be done, changing metric or metric type for specific routes, changing the AD for specific routes with BGP policy based routing. Okay. Now the types of route filtering are these all. Passive interface, distribution list, prefix list, and route map and policy based routing. Okay, these are the types of filtering things. We can do filtering with these types: passive, distribution, prefix list, route map, and policy based routing. So we started with passive interface. Okay, we started with passive interface. Now passive interface, we started with RIP. Passive interface, disable sending multicast updates via a specific interface, allow listening to incoming packets from other RIP speaking neighbors. If you are using passive interface with RIP. With OSPF and EIGRP, it is same. In OSPF, if we make any interface as passive interface, it works like it does it with EIGRP. Do not send any hello messages on passive interface. Okay, no neighborship. Still advertises about the connected subnets. Means you will still get the advertisement about the connected subnets. It is mostly used in LAN interfaces. Okay, on the LAN interfaces. Okay, same is there in EIGRP, because from LAN you will never get hello packets. You will never get hello packets from the LAN. So what you will do, you will make that interface as passive interface. Okay, why to waste your hello packets on that interface? Because you will not get any reply from the LAN users of the hello packet. Still you will be getting the advertisement of the connected neighbors if you have advertised them in the EIGRP. Then we started with distribution list. Now using distribution list is to control routing updates either that are coming to our router or leaving from our router. Distribute list work on a variety of different iOS routing protocols. Now, one of the easiest way is use an access list or a route. You can use a route map like we have seen, or we can see with the prefix list also. So we have seen all three of them: access list also, route maps also, and prefix list also, to permit or deny the routes. Now it can be applied to transmitted or received or redistributed routing updates. We have seen all these three. Okay. Then, like over here, what I've done, I have created a distribute list. See, on this router, what I've done, I have said distribute list 7, this access list number 7. What I've said, whatever network is there in this distribute list, don't advertise out of this router. Don't advertise in this direction, out of this network. Okay. So this you can do for specific network. You can do you can use redistribution list. Distribution list. Okay. Then what we have done, we have started with prefix list. Now prefix list is, what is the difference, Pawan, between prefix list and access list?
Prefix list is access.
I think so. You were the only one that was present that day. So I have explained you what is the difference between access list and prefix list.
Yeah, just give me a minute. Let me see my note.
Sorry.
Give me a minute. Yes, in IP prefix list we can use like less than or greater than or equal than some number of CID, some number of subnet.
You can say we can match the components of an IP route with the help of prefix length, the subnet mask value, like which was not possible with access list. Okay, if you see that day's recording, you people will come to know what is the difference. We have summarized the route. We have summarized the route of the 13 dot network. Okay, so prefix list, you can do it within this way, like this is my 10 dot network. Anything that is coming from 10 dot network and it is having a slash value as 8, okay, then either I can give deny or allow if anything is greater than slash value 9. Okay, if anything is having network as 10, starting with 10 dot network, and if the slash value is greater than 10, then deny that network or permit that network. Anything I can give as per my requirement, so which is not possible with access list. So we have seen how to use prefix list and how to deny the networks and all these things. Then comes route map, policy based routing. So policy based routing, we have already seen what is PBR. Okay, we have already seen what is PBR. Route maps are similar to scripting languages because they work with more sophisticated ACLs. They offer top-down processing. Once there is a match, it leaves the route map, and lines are sequence numbered. Insertion of lines, deletion of lines are easy. Route maps are named rather than numbered for easier documentation. Match criteria and set criteria can be used. It is similar to if-else logic.
We haven't seen if else logic, right?
Sorry?
We haven't gone through the if else logic, right?
No, that is something what we have seen. If suppose first route map is not true, then go to the second route map. That is known as if-else logic. What we have done,
Okay.
see, if-else means if, what is if? If I have given some condition, if this is the condition, if it is true, then run whatever is there in.
Okay. Done.
Okay, whatever is there in this. If the condition is not true, then run this else part. So what we have done, we have done the same thing over here. We have created route map CCNP. We have said deny sequence number 10, and we have said if the IP addresses matches in the 13, then run this sequence number. If it does not match, if this does not match, then you have to come on the other access list, other route map statement. Understood?
Yes, I got it.
If else statement is something, if something is true, then run this, else run something else. That is what we have done. If this IP address is whatever IP address matches with this access list, then run this sequence number. Whatever the set clause is given over here, run this sequence number. If it is not true, skip this and come to the other sequence number and check the other sequence number. Understood? Any doubt? PBR. Now common uses of route map, distribution, redistribution, route filtering, a more sophisticated alternative distribution list, PBR, and policy BGP policy implementation. So redistribution, route filtering, we have seen how we have filtered the routes. Okay, we have seen how we have filtered the routes in redistribution. Okay, so we have seen all these tasks, filtering routes using route maps. Okay, we have seen policy based routing. We have seen different tasks, source based, destination based, services based, then packet size based, then route maps for redistribution. All these things we have seen. You all can go through the recordings of previous lecture and today's lecture. If you have any doubt, you can ask me. Okay, understood?
Yeah. Yes.
Anything you want to ask?
No, I still have to review the last 3 lectures, and I'm sure I'll have questions. I'll ask him WhatsApp if that's okay.
Yeah, you can ask me at any time. Okay. So let us stop over here for today.